So my name is Chris Lionetti. I work for Hewlett-Packard Enterprise. However, I'm also a board member for Storage and Networking Industry Association. So Storage and Networking Industry Association and DMTF, Data Management Task Force, are two organizations that are formed by all of the partners in the industry. HP, IBM, Cisco, Dell, Lenovo, Supermicro, they all get together to write standards that benefit them all and help you, because when we all adopt the same standards, it actually is a very, very customer-focused thing. It really helps customers out. And we're going to go into exactly why that is. So it's important to know what came before. So when we want to manage servers, in the olden days, we used to use SNMP. SNMP was kind of the first protocol out there in 1990. That thing came out in the Windows 3.0 days. SNMP gave you the ability to pull information from printers, switches, all kinds of information. But it was built in 1990 with no eye toward security. The security was very, very simplified. And really the last update to it was in 2004. So it's not a very secure protocol, but it's a mostly read-only protocol. It's used to read information. And I should note, SNMP is great for reading some information like printers, because you've got nothing else. But I should note, SNMP defines a way to read information. It does not define how the information is stored. Each vendor gets to select how they store their information. They get to come out with their own MIB, or management information base, where they have all the dot numbers to tell you exactly what you're looking for. The dot number notation to get to the toner level on a printer X is going to be different than the dot notation to get to that same toner level on printer Y. And by printer X and Y, I mean brand X and brand Y. A individual vendor, like vendor Z, may have the similar O dot notation or OID to get to that toner information, but it's not going to be cross-vendor. But it is a very lightweight protocol. Lightweight's great. IMPI, or IPMI, is another protocol that was set out to let you control your servers and infrastructure to the point where you could put a boot image on a server, go ahead and boot that server, turn that server on, turn that server off, gather some information about that server. Again, not standardized. The method to make the calls are standardized, but the location of everything is a little different. They make a tool called the IPMI tool that lets you do all this stuff. Also very, very lightweight. But again, security was not a concern. They started developing the protocol in '98. It's been last updated or discontinued in 2015. However, most shipping servers still have some form of IPMI still on them. Vendors want to turn that off, and the reason they want to turn it off is it's a major security flaw. There's security problems with IPMI. Don't use it if you can help it. The benefit of both of these first protocols, IPMI and SNMP, is they're extremely lightweight. In the Goldilocks scenario, that was the first bowl of pudding. The second phase, when we changed over to use SIM, the Common Information Model. And then on top of the Common Information Model, we added something to do storage specifically, which was Storage Management Initiative. Now, these were also very, very highly used, very highly adopted, but they were, again, published in 1999, and they were built on a database format. So in other words, you'd have to actually store a lot of information to get that Common Information Model. That was a very heavyweight protocol. You see it employed in something like WS-MAN, or you can see it employed in Windows, for instance. It's deployed a lot in operating systems, but not commonly deployed in baseboard management because it's too heavyweight. So this is the third bowl of porridge. It's very heavyweight, it's very large, but it gives you a vendor-neutral way to contact information. So I could get the SIM information model for a certain server, and if it's brand X or brand Y, I can go to the same place and get the same information. So it gave me the uniqueness that I can actually hit all my vendors, but it was heavyweight. The perfect middle, or the Goldilocks bowl, was the one in the middle, which gives us that vendor neutrality, while at the same time giving us a lightweight operation. And that's the new Redfish protocol. In fact, this is the management infrastructure as we see it today. Because we've got a lightweight model that has no security, we have a heavyweight model that has security, but is extremely hard to implement. So we have this mishmash of management. So we're in the point where composable systems are starting to want to adopt this, because a composable system, you want to automate creating a cluster, creating software-defined storage, creating all that stuff. You want to automate all that stuff, and the way to automate that is to use a structure like this. What that means is you need a lightweight structure that can live on the server itself, not the operating system, but the server bare metal or the array bare metal, so that you can manage it and do all the things you need, but be cross-vendor. And that's the magic spot we're in right now. Composable systems really exposes this need. So, Redfish is made up, again, I tried to make a slide that had all the logos of the companies. The problem is there's 8 board member companies, 14 leadership companies, 39 participating companies, and 28 colleges participating in this. And then along with that, there's another 23 partnerships with groups like the Open Fabric Alliance, Gen Z, ASHRA, UEFI. There's all these different partnerships of people who are actually inputting information into the protocol so that they can actually use it for what they need it to do. Have you ever heard of ASHRA or EPA? So to be able to gather information about how much power your server is taking, those people want to gather it for that. So they have a very, very specific need, and they want to make sure the protocol supports that. So they partner with the Redfish protocol and actually write that. Now again, this is the Goldilocks scenario. You have something lightweight that can run on the server, in the ILO, or in the DRAC, or in the BMC, that will do this kind of thing. Now, I should note that vendor participation, this protocol they came out with this protocol in 2016. It got wide adoption by 2019. This protocol adoption is very high. I can think of all the server vendors in the market, I can only think of one that doesn't have Redfish support built in by default. So, and again, I'm not here to shame anybody, but almost everyone has it. In fact, not only does almost everyone have it, they all have it by default, meaning that it's on by default. Meaning if you've got a Dell with a DRAC, it talks Redfish whether you know it or not. If you've got an HP with an ILO, it talks Redfish. If you have an Intel with a BMC, it talks Redfish. You can talk to this protocol on any of these different platforms. Now, I should note, it not only talks to all these different vendors, but it talks all the way up and down the line, meaning that the smallest microserver, in fact, the little picture here I've got is a little server about the size of a shoebox. You'll notice that there's a little Ethernet port way over here on the side. Can't see my mouse. There's a little Ethernet port way over on the side here. That's your remote management port. That will talk Redfish directly to a server that's the size of a shoebox. And you can do things like power it on, power it off, inventory it, change the boot order, do all kinds of magical things. Now, if you want to go the other direction, the largest supercomputer in the world, they just added Redfish support. So you can go from the smallest servers in the world to the largest servers in the world, and everything inclusive. So Redfish is foundational. It's across the board. If your server is newer than 4 years old, you probably have it and don't even know it. So it's a protocol that's out there. It's out there, it was developed by the vendor at their cost, and it's free to you. This is what the Redfish protocol looks like. It looks like an API endpoint on the ILO, where you put the IP address of the ILO /redfish/v1, and then under there you have a whole bunch of folders, or a whole bunch of other extended endpoints. In fact, if you do a /redfish/v1, it'll come up with tasks, sessions, accounts, events, all this information. Now, of course, at this point you haven't authenticated. The first thing you have to do, because if you try and go down any of those paths, you won't get there because it'll actually give you denied. But if you go down the session path, there's a session token action, which you can request, and you put in your credentials for your BMC, username, password, or whatever credentials you have set up on your BMC, and that could be Active Directory integrated, it depends on your BMC. You put that in, it'll send you back an authentication token. Once you have that authentication token, you can then run any commands you want. And it respects all the different levels of support. For instance, you could have an operator-only type account on your BMC or your ILO or your DRAC, or you could have an administrative account and it could do different things. So it does understand role-based access control. But basically, under the service's root, you've got a logical view and a physical view. The logical view is things like if you create a volume. The physical view is I have a chassis, and that chassis has hard drives, and has fan packs, and has temperature sensors. So there's different views. And then under those, you've got your individual things like you've also got tasks, you've also got events. There's a lot of things that are built up under that. So again, anything you want is under this view somewhere, and things cross-link. So if I go to system, and I go into my system and look at volumes, the volume will point to the drives that volume sits on top of. Let's say it's a RAID set. It'll point to the volumes that drive sits on top of, and then if I point to those drives, Those drives can point to the chassis they live inside of, and the chassis can point back to the system they're a part of. So the whole thing wraps around. And in fact, this is what the protocol, this is what this is called a mock-up. So I went ahead and went to that link, and actually, let me hit escape here. Hold on. There we go. So you should see my screen here. So you can go to publish mockups, and you can take a look at the mockups. So a simple rack mount server, if I go to the mockup, this is going to give me an example of what a single node server looks like. I can explore that mockup. And again, you can go to this from any place you want. And you'll see under Redfish v1, I'm going to have a bunch of data fields, and I'm going to have some complex items. You'll notice under systems, I've got something called an OData ID. And that OData ID points to systems, which is a collection. Now, if I click that, I follow the path down to that. Now, I've gone down to systems, and under systems, you can see there's a serial number. And there's another OData ID because it could be a composable system, and I could have 4 systems together, and all 4 of them would show up. But I have one system, and there's a serial number, and I can click on it, and there's the information about that system. The asset tag, manufacturer, model, submodel, SKU number, serial number, all this information is pullable. But more importantly, if I keep going down the list, you can see things like my boot order and how those are set. Now, these are not read-only items. A lot of these things, some things are read-only, some things are read-write. And I'm going to show you how to get to the protocol to see how that works. But you can see that boot source override mode is UEFI. You can see all the different features that are built into the return data. It's very deep. If I care about the BIOS settings of that server, so again, I've gone into systems, then I went into my individual system. Now I'm under that system and I want to look at the BIOS. I can go into that BIOS setting, and now I'm looking at the BIOS setting for that server. And you can see different attributes for the BIOS. So I can just keep walking down the model as far as I want to go. BIOS settings. So you can see the different path I'm following to get down the list. If I go to systems, or Redfish v1, if I go to chassis, here's my 1U chassis. Under the chassis, here's all the information about that chassis. If I care about thermal systems, there's my thermal information. If I care about my fan packs, here's my fans. If I care about the fan in bay 1, here's my fan in bay 1. I can get RPM, I can get the speed readings, percentage, I can get all kinds of information. You can just pull this information from any server out there. And again, it's just iteratively walking through the tree. But the benefit is, these models, these features, these values, manufacturer, part number, are the same vendor to vendor. You're not going to have a situation where part number, it's capital P for part number and a capital N, part number. On a Dell, it will also be a capital P and a capital N. On a Cisco, it will also be a capital P and capital N. For status, notice it says state and health. Well, the values for state and the values for health are predefined in the spec. They can only be returned to certain things. So you can guarantee you're going to get the values you expect back. That's the key. Is a lot of APIs, you make the call to the API and you don't know what you're going to get back. But in this, what you get back is actually predefined. So the vendors have to give you back exactly what they expect to give you back. Now, to go with that, that's what the mockups look like. I talked about the spec a second ago, and here's what the spec looks like. Here's the official Redfish spec. And by the way, this is updated approximately every 3 to 6 months. This is the spec from, December of 2023. And you can see I can go into here. Let's go to something we all know. How about drives? Drives is a good one, because people know what drives is. Notice I've got versions here. 2023.1, 2023.3, 2021.1, so here are all the versions when those versions came out. But more importantly, here are the URIs those drives could be hidden under. But then if I go down here, you can see all the different values. You also see the spec, it's all open. It tells you what the value of the type of the data is. It tells you what the read-only value is, or if it's read-write. So you know what's patchable and what's not. It tells you, in the case of something like RPM, it'll tell you that it must be an integer between these two values. So certain things, it fills in what they're allowed to be. Trying to find a good example of that. But for instance, drives. If I have a drive and that drive has a number of volumes defined on it, the drive points to the volumes it's defined on. I can then follow to the volumes to see where those are. So you can see the spec is really powerful. In fact, let me continue on. So that's how the REST API works. Swordfish, now we talked about Redfish. Swordfish is an extension to Redfish that simply adds enterprise storage. And what I mean by enterprise storage is SAN-based storage. Fiber channel, iSCSI, NVMe OF. Now that's important because the old protocol like SMIS was discontinued before NVMe OF was even a thing. So those protocols won't handle it, neither will IPMI, but Swordfish and Redfish do. And in fact, Swordfish and Redfish are the same protocol. To get to a Swordfish endpoint, you actually go to redfish/v1 and you simply have the exact same Redfish model you're used to, but we've added a couple folders. What folders would you need to add to support enterprise storage? Well, you need to add storage pools, because when you do large-scale arrays, you're going to be making these pools that have thousands of volumes in them. We also added remote replication, because an array commonly does remote replication to another site. We've also added things like fabrics and endpoints, so that you can actually set up an iSCSI initiator or a fiber channel initiator so that you can map a volume to an individual host that's outside of itself. And again, those are read-writable, those are changeable. You can actually map things directly that way. Now we have a number of partners. Again, Redfish is adopted by everybody. Swordfish is a little bit more new. And what I mean by new is that we haven't had as many adoptions. There are some arrays out there that do support Swordfish, but the number is actually very low still. However, NVMe drives and NVMe OF drives are going to have to support Redfish and Swordfish because that's the default mechanism for managing them. So again, what we're looking for is we're looking for people to start adopting these more. Redfish is done. Use it to your heart's content. It'll do everything you want to do with on-site stuff. Swordfish, on the other hand, we're trying to get people to put those into RFQs. To be able to bang your vendor and say, hey, you should come out with a Swordfish because I want to be able to manage this open standard, to be able to insert it into the Open Fabric Alliance, or to be able to insert it into SOTA, or be able to insert it into some other group. And they're going to talk Redfish because it's easier for them to write the application once. What people don't want is they don't want to have to write a PowerShell toolkit, or they don't want to have to write commands that work against one vendor's individual type array. They want to write one command that works across everything in the market. So Swordfish, again, looks just like Redfish. The difference is we've added a few things. We've added fabrics, we've added NVMe OF and NVMe namespaces, and we've added adapters or initiators. Now, you'll also see that we're starting to do something called the Open Fabrics Management Framework, OFMA, or OFMF. With that, we're trying to make it so that Swordfish and Redfish can manage your actual switching infrastructure as well. Because if you're building a cluster and you want to actually have storage area networks, you want to have servers, you want to have everything interconnected, even if you don't want SAN, if you just want composable systems where the switches configure themselves with everything else, you want the fabrics to be controlled in the exact same way and to have them multi-vendor. So OMFA is actually helping us with that. So here's what the REST API for Swordfish looks like. And again, it's very similar. The API spec is, again, it's been worked on for years. We've got the version control. We've got all the people that participate in writing the protocol. And then we've got all the different things like fabrics, endpoints, consistency groups, storage groups. So you can see that we've added a bunch of stuff. The volume resource. Now, whenever Swordfish, the team that developed Swordfish, finds something that should exist in the Redfish model, because Redfish is the server guys, Swordfish is the storage guys, they actually throw it over the wall. And the Swordfish and Redfish people, there's a lot of people on both teams. So it gets to the right group. There's not animosity between the two groups. The two groups participate with each other very, very well. So when the Swordfish guys said, we need to add some things to drive to make it work in a SAN, the Redfish guys said, yeah, well, that could actually work in a standalone server as well. Let's put it into the Redfish model and keep it there. So there's a movement between the two. So again, the specs are very, very well documented. In fact, I think if you want to play around with writing a PowerShell toolkit to expose an API and actually use the API, this is one of the best specs out there for doing that. In fact, here's an example. You'll notice that most of the things I'm doing live in the Redfish space. But the Redfish stuff points right to storage services or to storage to be able to handle more intricate things that depend on an array to do, like storage pools, lines of service. So you can see that the models are actually interdependent. But again, there's no reason for a SAN array to have to redefine how chassis works. They just simply implement chassis just like a server does. A chassis is a chassis is a chassis is a chassis. So there's no duplicative effort here. But again, everything is defined out and everybody is equally set up in the sense that anything you run in Swordfish on one array should work on the other array. Again, just like with Redfish, we have mockups. And if you go to mockups, Ethernet attached drive with NVMe fabric, enterprise box of flash, NVMe SSD with endurance groups. We've got a bunch of mockups out here. In fact, the one I like to bring up is probably one of the simpler ones. Mid-range array. Here's my chassis. If I care about my storage folder, I can take this, go up to here, and treat it just like I was before. In this, the name of that server, that mid-range storage array is called mid-range storage array. Whoop. So I can go into here and you can see I can actually see my storage controllers and walk in the exact same method. Notice for drives, I have a whole bunch of individual drives because it's a storage array. It's going to have a lot of drives. Now, to help with this, so we've got the documentation, we've got the mock-ups, so you can go online without even owning one of these arrays and actually see what they look like when you implement it. So you could look at the API, then you could look at an actual finished implementation to see what those things look like. We also have Docker instances. So if you would rather run your own instance of an array that lives on site that responds to Swordfish or Redfish, we have both Docker instances for Swordfish and Redfish. So in fact, you'll notice if you go to Docker, and you type in the keyword SNIA, you'll see we have a Swordfish API emulator, we have an Ethernet attached drive mockup, we have direct attached drive mockups, we have NVMe enterprise box of flash mockups. Again, you can type DMTF and find all the mockups for Redfish servers. So you don't actually have to have one of these servers to run a Docker container on your machine that you can connect to and actually run these commands and try out. So we've tried to make it really easy to run this stuff, really easy to learn. Now, this all comes to the fact that what we did is we ended up building a Swordfish PowerShell toolkit. And you'll find it here, which is SNIA's site. It's called the Swordfish PowerShell Toolkit. Now, the Swordfish PowerShell Toolkit, remember, Swordfish and Redfish are the same thing. And in fact, when you import this toolkit, it will run Redfish commands and Swordfish commands identically. There's no difference. All we did was add an alias to the Redfish commands to call them Swordfish commands. So it's the exact same command, it's the exact same call. But this right here gives you the ability to run, let me bring up the desktop, PowerShell. Let's open this with VS Code. And you're going to find that this module has got a README of exactly how to use it. But more importantly, it's got all the commands you could possibly want. It's got import module. So you can see we've got the commands to do exactly what you're looking to do. If you want to query the information about the certificate store, about the chassis, about the thermals, about anything, it's all there. Now, unfortunately, I was going to be VPN into the SNIA labs because SNIA has got a lab that they run for DMTF, which has got a vendor server of all these different vendors. So we've got HP servers, Dell servers, Cisco servers. We've got all these servers set up so that we can actually test the toolkit and test other applications to make sure they run cross-vendor. So every one of these tools has been tested across multiple vendors. Now, unfortunately, I can't run the commands to show you that. However, I can show you what they look like. In fact, the first thing you're going to do is you're going to go connect. Come on, mouse. Give it back to me. Connect Swordfish target or Redfish target. And you're going to give the IP address, like 1.1.1.1. You can put a port or choose a default. You could do the protocol, and the protocols could be HTTP or HTTPS. Obviously, it'll default to HTTPS. But once you connect it to the target, it will actually make that the default target to connect to. Now, once you've done that, however, you're not actually connected to the point where you can run commands. You just discovered that a Redfish endpoint exists. At that point, you want to do a get Redfish session token with a username, a password, and what that'll do is it'll bring back the authentication token. Once you brought back the authentication token, all the following commands will work. Every other command in the toolkit will work. Now, I can't really show you what these commands look like when they're running. However, if you take a look, there's an examples folder. In the examples folder, we've written the tests to automatically put the output of the tests into the example folders for us by default. So if I run a get Redfish drive, you will see get Redfish drive dash return collection only. It looks like that when it returns. If I return that same command, except don't put dash return collection only, remember, I can either look for all the drives or I can return just the collection of drives. So I wanted to return all the drives, it looks like this. And this is the actual output. I put get Redfish drive, convert to JSON. The reason I did that is because it's a multi-layered object that comes back. But you can see all the information that comes back. So this is what the actual command looks like when it runs. And in fact, you can actually find this directly from the GitHub site. So if you go to the GitHub site to download the PowerShell toolkit, you can actually take a look at the tests we've written to actually exercise this thing. You could look at the examples. In fact, the key here is, see how it says there's a master? Go to the include draft examples. If you do the include draft examples and look at drives, you'll see all the different servers that we've tested this against. Like, here's what the response is from a Dell. In this case, it's a Dell PowerEdge R610 server. And that's a live example of what that output looks like. So you can see exactly what it looks like. I can do the exact same thing and see what the JSON return is from an HP. And again, I read the JSON a little easier than I read the text. But it is returning a full-on PowerShell object that you could dig into and use any way you want. And again, this is a HP ProLiant DL360 Gen 10. But you can see it's all the same thing. It's exactly the same command run on two different platforms, and it just runs. Intel, exact same thing. So the fact is you can pull back the information from any of these platforms. Is this making sense? And again, the PowerShell toolkit's free. The Redfish and Swordfish protocols are also free. These exist and work on your existing environment. The usage I expect people to use, say you've got 100 servers on your site. The biggest fear as an IT guy for me used to be, what if somebody walks in, yanks a hard drive, puts a replacement hard drive in that's exactly the same, and the PCI RAID controller in the server rebuilds that drive? How do I know what happened? How do I know that somebody didn't just walk out of my site with a hard drive full of data about my infrastructure? Well, that's easy. You write a simple PowerShell script that scans every single one of your servers every day and compares the inventory that existed in it today with the inventory that existed in it yesterday. And if anything's different, it flags you. You could also tell it, automatically inventory my entire infrastructure, query every server I have, and tell me how many of my power supplies have failed. Tell me how many DIMMs have single-bit memory errors. Automatically download the event log in BIOS for every single server in my infrastructure daily to store in a centralized log server. All of these are good cases for you to use Redfish to do these things. How would you pull this data any other way? I don't know of a way to do it. I don't know of a way from any vendor to be able to pull the event logs from BIOS on an entire infrastructure on a daily basis, inserted into Prometheus, for instance. Wouldn't it be nice if you had 1,000 servers in your data center and you know the location of every single one of them? Wouldn't it be nice to feed that into Prometheus, which then feeds into Grafana, gives you a map of your data center and lets you monitor it for hotspots? Oh, this server's getting hot over here, or this entire rack of servers is getting hot. Once you can visualize where the hotspots are, you can know to fix things. But of course, all of this depends on visualization. You can't visualize any of this if you can't get it. And this is the protocol to get it. So again, the PowerShell toolkit is there for you. Again, the Redfish, Swordfish protocols, you can see that everything in red is Fabric stuff. Everything here in purple in the middle is Swordfish and Redfish model. Everything in white is stuff we've recently added for NVMe. And you can see the Open Fabric Alliance is trying to get more Fabric stuff in. So we're constantly updating this and improving it. The Open Fabric Management Framework, we have a whole bunch of people already involved in this. A lot of people you know, a lot of new technology. So we're not trying to monitor and manage 12-year-old switches. We're trying to monitor and manage the switches that are all beta right now. We want, when they come out from day one, for them to support Redfish and Swordfish, to be able to give you the ability to monitor your switches as effectively as you can monitor your servers. So this is a protocol that's growing on a daily basis. We're adding things to it all the time. And these are all links that you can go to get more information. And again, there's a lot of information out there on this. It's probably the best documented API on the market. Possibly the exception with the Pokemon one, because that one was really good. But this one is extremely useful and extremely well documented, and it's all free. The vendors have gone out of their way to make sure things interoperate. Yes?
Push configurations. Could we set up a pass from a iDRAC or change the configuration, push a certificate?
Yes, you can. You can push certificates to your ILO or DRAC or BMC. You can change your boot settings. You can turn off CPUs. You can change your fan speeds. You can do anything that you can do from ILO and DRAC and BMC, you could do from Redfish.
Potentially could set up a provisioning endpoint.
Yes, you could. You could have the provisioning work very similar between a Dell and an HP, even though they're completely different and would have different steps in ILO and DRAC. The Redfish could make it all seem like the same thing. So what you're doing here is you're really giving yourself an out when it comes to automation. If you can't automate it, should you really do it? If you can't automate it, why wouldn't you? And again, you look at the protocol and you look for all the fields that are read-only versus read-write. If it's a read-write field, you can modify it, you can change it, you can set something. And you'll notice also that in some of those fields and some of those returns, you're gonna have a folder called actions. In the action folder, you'll have actions like initiate secure erase. So if you have a drive, if you monitor every single drive in your environment, you could set up a script that monitors every drive in your environment. And there's a feature in each drive called write endurance or predictive failures. If you monitor your predictive failures and write performance, and you detect that you've got a drive that's going to do predictive failure, and you know you have a hot spare in that system, why wouldn't you fail over the hot spare? Then issue a secure erase to the drive that was about to fail. Because that way you can do a secure erase to the drive before it fails, so that you don't have a drive that leaves in a failed state with customer data on it. Admittedly, the best thing to do would be to encrypt it before it ever got to disk. But what do you do if you didn't do that to start with? These are all automation methods. These are all methods that you can use to do this kind of thing. And is this all making sense of how this can be used, what you can use it for, the value prop? And you're probably thinking, why would HP, why would Dell, why would Cisco, why would Lenovo want to have this open standard? Because if a management company comes out, like SolarWinds, and says, we can manage that Dell server because they have an API that we talk to, we would like to, at HP, Cisco, Lenovo, say, oh, we'll use the Redfish protocol to manage that Dell. Magically, it's also going to work on us now. So all the management vendors get to manage one system and pull in all of them. So we get to level the playing field across vendor. And then the last slide I've got is the QR codes to get all these tools. But again, you're going to be able to download the slide deck after the conference and be able to grab all these links as well. And in fact, I'm going to put this on the Slack as well, so you guys will be able to download from there as well. Any other questions? Yes?
Yeah, are there any other configuration management solutions, like using Ansible modules or things like Redfish and Swordfish? You already have those?
Well, that's the funny thing, is Open Fabric Alliance and Soda and people like that, what they're looking is giving you the ability to run a whole bunch of Ansible commands or Puppet commands, that kind of thing. And then under the covers, they're calling Redfish.
Right.
So it's actually good. We don't care where you're calling it from. There's a lot of middleware vendors who are calling Redfish that give you their own plugin. It's kind of like how Docker had volume plugins to be able to manage individual storage, so that the person who ran Docker didn't have to understand the API for the end device. They got to run a command that's local, that's understood by a Docker user, but the end array still gets to respond with a standard API. Now, hopefully next year, I'll do a redo of this talk. And by next year, I'm hoping to have a Prometheus pump all set up, as well as a Grafana dashboard for a site where I've got many, many different vendor servers, so we can actually look at this stuff live. Now, additionally, the PowerShell toolkit is not complete. The protocol for Redfish is massive. So what I've done is I've implemented most of the get stuff, but I've not implemented all of the many of the puts and the posts. So if any of you is interested, it's a community-sourced PowerShell toolkit. SNIA is community-sourced, which means if you want to go ahead and clone this repository, and you want to write a command to do a specific something, that you want to do something to your environment, you want to push, change boot order, things like that, and write a command, and go ahead and submit it back, do a merge request, we'll take a look at it, we'll test it across vendors to make sure it works cross-vendor, we'll modify the code if it needs to be to work cross-vendor, and then we'll add it to the toolkit. The toolkit is in your guys' hands as much as it is ours. If you want to play around with learning a new API, this is a great one to learn, and you can get your name listed in one of the authors of the toolkit. So join us, help us write it, help us make it more powerful. Help PowerShell be able to manage everything, manage all the things. Any other questions? I was told I had to get out of here at exactly 1:45, because if any of you are late to the lightning talks, they're going to take it out on me. So I want to make sure that we respect that. However, what time is it? So we have 5 more minutes if we have any other questions. Otherwise, I think we're good to go. Please do your reviews if you get a chance, not just on this session, but on others. Definitely lie and say this was the best session you did. I will tell you an interesting one is my company bought Cray Computer a couple years ago. And we have a policy that every server we ship for the past 5 years, Redfish is the default. We put Redfish on everything. So when we bought Cray, they're like, well, Redfish doesn't do liquid cooling. We're like, oh, well, that's not a problem. We're a member of DMCF. We're going to bring liquid cooling in. So the guys at Cray got to write the spec for liquid cooling to add into Redfish. Now, you'd think we just put that in the protocol, but we don't. What we do is we have to go to the symposium and submit the liquid cooling spec at which point Dell gets to vote on it, Cisco gets to vote on it, Lenovo gets to vote on it, and all of us get to vote together to make sure it's industry neutral. So no vendor gets an upward hand in the protocol development. All of us have agreed to the protocol. That's what the magic of working with these standards is. Additionally, these protocols are written by all the members who pay to be members. So HP, Dell, we all pay for the privilege to actually work on the spec. And in fact, everyone who works on the spec is a volunteer. All of these specs were written completely by volunteers from their prospective companies. So it really is an altruistic method of doing spec design.
Awesome.
All right, thank you guys. All right, appreciate it.